All right, number 15, we want to know the domain of the function. So I haven't really spent time talking about how you find the domain when you have an equation. We talked about we can see it on the graph. When we have order pairs, we can list it. But now we have an equation. So without trying to give you too much of an information overload, there's two main types of equations that you will see. You will see what we call a linear equation, like y equals mx plus b. Okay, we will know this is linear because the exponent on the y is a 1 and the exponent on the x is a 1. Okay, whenever you have linear, the domain is going to be all real numbers or negative infinity to positive infinity. So we'll just say all real numbers. I do the pound sign for numbers. Okay. The next probably common type of equation you'll see is quadratic. So y equals ax squared plus bx plus c. So something with x squared. So the biggest exponent on the x variable is going to be a 2. Whenever you see that, this is a quadratic. You'll know that because the largest exponent on the x will be x to the second power. And again, the domain will be negative infinity to positive infinity, or all real numbers. When we're asking what is the domain, we basically want to know what numbers can you plug in for x and get an output for y that you can actually solve. Okay, so there's really 3 areas that will cause a problem. One is if you have a fraction, specifically with x in the bottom. The reason why this is an issue is because we can't divide by 0. So here's what we would have to do. So let's say I had y equals 1 divided by, x plus 2. Okay. In order to find the domain, I take the bottom only. It doesn't matter what else is going on. I only focus on the bottom, which is going to be x plus 2. And I tell myself that this cannot be 0 because I cannot divide by 0. And you solve for x using this as your equal sign. You would subtract 2. And you would get x cannot be equal to 2. So this would be our domain. X cannot be 2, which means I can use any other number that I want. Meaning I can go from negative infinity all the way, no, this should be negative 2, I'm sorry, all the way up to negative 2. And then I would have to stop at negative 2 and then go to the other side of negative 2, and then I can go to positive infinity. It's like taking a number line and then like removing this one point, and then it separates your number line into 2 pieces. This side and this side. Okay, it's like making a gap. And so that's how we get those 2 parts. So just for example, if I had another one, I could say y equals 5x plus 3 divided by 1 minus x plus 6. Again, I have this situation where I got a fraction in the bottom. All the rest of this stuff doesn't really matter right now. I'm just focusing on the bottom. So the bottom cannot be 0. So I would do the same thing, only the bottom. 1 minus x cannot be 0, and then you would solve the bottom. So no matter what else is going on, this is one issue that would cause you to have a domain something other than all real numbers. But for the most part, it's going to be all real numbers unless you have this scenario, something with a fraction in the bottom, or I'm going to give you the second one that you might see. Second issue, there's another one, but it's beyond the scope of this course. But the second issue you might see is a square root. So if I had an equation, y equals, let's just say, square root of x minus 6, let's say plus 3. It don't matter, I can put whatever. The issue is the square root. Okay, so when we take the square root, we cannot take the square root of a negative number. Okay, so whatever's under here has to be positive, so that's my restriction. So I only focus on what's under the square root, and I say, okay, x minus 6 must be greater than or equal to 0. It can be equal to 0 because the square root of 0 is 0. 0 times 0 is 0. But whatever else is under there, it needs to be positive or 0. So I do this. Whatever's under the square root, greater than or equal to 0. That's the rule. With the fraction, you have to do not equal to 0. This one, you got to be greater than or equal to 0 every time you have a square root. And then I would just add 6 to both sides to solve this. And that would give me x has to be greater than or equal to 6. So this would be your domain here. Any number that's 6 or bigger. The way you put that in what we call interval notation, because of the equal to, we would put a bracket 6 all the way to infinity. The arrow's pointing that way. So again, these are the two general rules that you'll see, but for the most part, you will see these types of equation, and your domain is going to be all real because you don't have any problem areas. You only have problem areas if you have a fraction for right now with x in the bottom, or if you have a square root with x under the square root. You got to solve it to be positive. This one you have to solve not to be 0. So with the function that we are given, there are no issues. We don't have a fraction, we don't have a square root, so the domain is going to be all real numbers, or negative infinity to positive infinity. Okay, nothing that you have to solve. Now here is one that has an issue. Okay, it has that fraction in the bottom. So that's this scenario. So what we're going to have to do is we're going to have to take the bottom and say that this cannot be equal to 0. Let's do that. I'm going to say h of x equals 1 divided by x plus 9. Now, as we just previously mentioned, whenever I have x in the bottom, this is a problem because I cannot divide by 0, so I got to figure out what makes this 0. So I'm going to say x plus 9 not equal to 0. And then I'm going to subtract 9 to get x by itself. And that's going to give me x cannot be equal to negative 9. So imagine I got a number line with all the numbers on it. Goes from negative infinity to positive infinity. I'm removing one point, negative 9. So let's say negative 9 is right here. This point is being removed, so it's like separating this into two pieces. Negative infinity to negative 9, the left side of negative 9, and then I have to do this union symbol, negative 9, the right side of negative 9 to positive infinity. So I can get everything except for negative 9. It's like a hole. So imagine if you were like on a road and then there was like a gap. You couldn't get across because I've removed that number 9, and so it makes a hole. And so that's why we got two pieces. It breaks my number line into two pieces. So they want interval notation, so they want it like this up here. So I'm going to say parentheses negative infinity, comma, negative 9. And then here's that little union symbol, means I got another piece that I'm connecting. And then negative 9 to infinity.